All right, for our last lesson, we are going to take a look at circle graphs, also known as pie charts, as well as some measures of central tendency. So that's going to include mean, median, and mode. So for this warm-up question right here, I just want you to take a look at this graphic. I want to see if you can figure out what they're trying to represent. I want you to look and see if you think it's a valid graphic, if it's actually a good display of the data. All right, hopefully you had a chance to look at it. First off, I'm not necessarily sure what this is trying to represent. There is no title to this graph. I can maybe imply that we're looking at, maybe like a pet choice, possibly, but that's just my best guess. Now, is this a good representation of the data? I would have to argue no, because if I'm looking at this and I want to say, hey, what's the most popular pet that a person can have? I'm looking at this horse column right here because the horse column is the one that sticks out the furthest. So that's making me think that the horse is the most popular pet. However, it looks like if we actually count each individual pet, so like if I'm counting the cats, I have 1, 2, 3, 4, 5, 6, 7 cats. I have 5 dogs. I have 3 horses and 3 that fall in the other category. So looking at this, there's definitely the most cats, but I don't get that represented visually within this picture because cats are actually only the 3rd longest bar here. So for one, I don't know what this is actually trying to represent. And number 2, it's not a very good scale here. That's another kind of bad reason why to use a pictogram or pictograph is because you need to have the icons be the same size to actually get a good representation of what you are working with. All right, let's take a look at the pie charts or the circle graphs here. So we're working with a used car dealership that sells cars and trucks, and it looks like the title of our graph here is going to be the vehicle distribution by make. So there's our answer to question A. What is each sector representing? Well, each sector is representing the number of cars sold by each make. So for example, this right here, this slice of the pie would be our Toyota slice. We would know that 13 Toyota vehicles were sold. See how many total vehicles are represented? Well, add up each of the numbers of vehicles that are sold. So 13 plus 10 plus 6 plus 3 plus 18, I'm pretty sure gives us 50 total vehicles that are sold. D, how many of those are Toyota? Well, I can go ahead and look at my Toyota sector, and 13 of those are Toyota. How many of those are not Toyota? Well, what I can do here is I can either add up everything else, so the 10, the 6, the 3, and the 18, or if I know there's 50 total vehicles and 13 are Toyota, that would tell me that 50 minus 13, or 37, would not be Toyota. So what percent are Toyota? Well, if I'm looking at a percent, I'm going to see how many are Toyota out of the total number. So 13 out of 50, if I go ahead and do that division, I'm going to get 0.26, and then we just need to translate that into a percentage. So I'm going to multiply that by 100. So 26% of these vehicles are Toyotas. And what percent are not Toyota? So if 37 out of 50 cars sold are not Toyota, I can go ahead and do that. So that is going to give me 7.74. So as a percentage, that would be 74%. Notice I also could have done 100% minus 26% to get that 74 because the total is 100%. And if I take away the 26% that are Toyota, that would leave me with 74% that are not Toyota. What percentage of vehicles are either Ford or Chevy? So it looks like we have 10 Fords and 6 Chevys. So if I add those two together, that gives me 16. So now I'm looking at 16 out of 50 total vehicles. So as a percentage, that would be 32%. And then question I, how many times more Hondas are there than Dodges? Well, let's take a look. Our number of Hondas are 18. And our number of Dodges that have been sold are 3. So 18 divided by 3 is 6. So we sold 6 times more Hondas than Dodges. So this is just, kind of going through answering some basic questions about a particular pie chart. Let's look at a second one. So this would be an online movie rental site. They have 20,000 different titles. It groups its movies by collection. So we have horror, comedy, children's, action, and general interest. So here we go. What is the title of the graph? Well, our title is going to be the movie collection by category. For K, how many different titles does this movie rental site have? Notice I don't get that information from my actual pie graph right here. It doesn't have the number. It has the percentage that fall within each of those particular categories. So I need to go back up to the original problem. There's actually 20,000 different titles. And then for L, what does each sector represent? Well, each sector is going to represent the percent of movies by category. And then M, how many movies are action movies? So here I know the percentage. There's 12% that are action, but I actually want to know the specific number of movies. So I'm going to take 12% and convert that to a decimal. So that's going to be 0.12. And I'm going to take 12% of the total number of movies. That's going to tell me the actual number of action movies that this site offers. So if I type that into my calculator, I'm going to get 2,400 movies are actually action movies. And then how many movies are general interest or children's? So general interest, I'm going to see what my percentage is. It's going to be 56. Children's movies are 18%. So I'm going to add those two together. That's 74%. So now I'm going to do the same thing that I did in M. I'm going to take 0.74, so I'm converting that percentage to a decimal, and I'm going to take 74%, so 0.74 of the total number of titles. And if I go ahead and do that computation, I'm going to get 14,800 of the movies are general interest or children's movies. All right, here's another graphic that I stole off the internet as far as like a misleading graph. I'm going to give you a spoiler alert here that this is definitely a misleading graph, but I just want you to look at them because again, when you see these, you don't automatically assume that they're not going to be telling the truth or the full picture of the data. And that's kind of a bummer because, you know, when you have a very short news segment time, you really want it to be a good representation of the data. So let's take a look. How much is this arena going to cost? So if we're actually looking at the total cost here of our arena, then we need to add up all of these values right here. So we're going to take 265, we're going to take 10 million, we're going to take 85 million, and we're going to add 50 million to this. So I'm going to keep all my answers in terms of million, just so I can keep my numbers a little bit cleaner looking. So I'm going to go ahead and add all those up, and I get 410 million. What percent is the city going to be paying for? Well, if I look at the city is chipping in 265 million out of the total. So I'm going to go ahead and do 265 divided by that 410. And that tells me that the city is paying for about 64.6% of the overall arena that's being funded here. So if I'm just kind of compare this 64.6% to what I'm looking at in my circle graph, I'm expecting that to be more than half of the graph. So what I see over here in the graph is this actually looks a lot closer to 50%. It looks like it's straight down the middle versus being more than half. It should be about 65% of the graph. So right away, that's kind of jumping out at me as not good. What percent is AEG paying for? So AEG is going to pay 50 million out of the total of 410. So let's figure out what that percentage is going to be. And if I type that in, I get about 12.2% that AEG is going to be paying for. And if I'm looking here, this looks, I don't know, definitely not like, I'm expecting like 12% is pretty close to about 10% or so. And it definitely doesn't look like it looks like it's a bigger wedge than what they're actually paying for. What percent are the Maloofs paying for? So let's look at that. We have 85 divided by 410. And if I do that computation, I'm getting just over 20%, about 20.5%. And it actually looks like this 50 million and this 85 million are almost the exact same chunk. And then what percent is coming from unknown donors? So 10 divided by 410 gives me, about 2.4%. So this 10 million right here should definitely not be that big of a slice of the pie. So again, just things to think about. It really does pay to kind of double check graphics just to make sure you are getting a good representation of the data. All right, so let's look at measures of central tendency. So measures of central tendency are going to include mean, median, and mode. So these are probably things that you've been dealing with quite a bit, in and out of math class. So what I want you to do is just take a moment and go ahead and look up these 3 definitions here. Just Google them, see what you come up with, and then I'll share my definitions with you. All right, hopefully you had a chance to go ahead and look these up. So if we're looking at the mean, another word for mean is the average. So mean and average can be used interchangeably. And what you do to find the mean or the average is you take the sum of the values. That means you add up all of the numbers that you have and you divide that by the total number of values. And that gives you the average. Now, the median is going to be the middle number when the numbers are ordered least to greatest. So they do need to be in order. So a lot of times the data will be given in order to you, but if it's not, you do need to do the extra step of actually putting them in order. So I have 2 little kind of subcategories here for the median. So if the number of data values is odd, the median is just going to be the middle number. So meaning we don't have to do anything special. If there's an odd number of data values, so say there's 3 data values, your median is just going to be that number in the middle. If the number of data values is actually going to be even, then it's going to be the average of the middle 2 numbers. Okay, so for example, if you have 4 data values, okay, your median, so your number in the middle, is going to be the average of these 2 numbers that fall in the middle. And then lastly, our mode is going to be the number that appears most often. So let's take a look at some questions. We're going to have a small business. There's 5 employees. You can see their yearly salaries below. So how many employees are there? There's 5. You can either get that up here from the problem, or you can just count how many yearly salaries there are, and you'll see there's 5. And what is the mean of the yearly salaries? Well, add up all of these values. So I'm going to add all of those up, and I get 196,000. And if there's 5 total employees, I'm going to divide that by 5. So if I do that, I'm going to get 39,200. So that's my mean or my average salary. And I'm just going to kind of look at my data values, kind of go back up and compare. Just over 39,000 down here is my mean. And I look at it, I see 42, 36, 45, 35, and 38. That definitely seems like a reasonable mean here. Okay, it's not something that's really far off. I feel good about my computation, and I feel like that's definitely in line with the data. Now, continuing on here for C, suppose the owner of the business makes $218,000 a year. We're going to find the mean salary for these 6 individuals now. So that means now let's include that $218,000. So if I add that in, that makes my total sum now $414,000, and I'm going to divide that by 6. And if I do that, I'm going to get $69,000. So if I'm looking at that and I'm comparing it to the original data values right here, I guess we can add our 218,000 in. Okay, 69,000 now really seems kind of out of line because majority of the workers are making a lot closer to about $40,000 or so. And then this kind of outlier, this owner salary of 218,000 is definitely skewing our average right here. So my next question, which mean would employees use to argue for a raise? Well, they would use the 69,000 because they say, hey, here's the average salary of the company and I'm only at like $35,000. I think I definitely deserve a raise because the average salary, is more than $30,000 more than what I'm making. And then so like question E, which mean would the owner use to argue against giving raises, well, they would probably use that $39,200 average salary because they're like, hey, this is the average, salary for these 5 workers, and you're right in line with that 39,000 for the mean. So just kind of something to think about, like something that might actually come up like within a context of your life. So last one here, F, which mean is best to represent the average salary of the business? Well, I would definitely say the one without the outlier. An outlier is just something that really doesn't follow the pattern of the data. All of the data values for the 5 employees were right around $40,000, give or take a few thousand. And then once you added in that owner's salary, it really skewed the data. That $218,000 just wasn't in line. It was significantly higher. So we would want to use the mean without the outlier. So we'd want to use the $39,200 mean because that's a better representation of the data. Now let's look at G here. So for G, we're going to find the median salary. So what we need to do is we need to put these in order. And so I'm going to just do these in terms of thousands of dollars. So I'm going to go in order. Now, when I'm doing this, I'm going to go back up to my data and I am going to scan and I want to find the smallest data value here. So my smallest data value looks like it's 35,000. So I can go ahead and cross that off. My next smallest is 36,000. So I'm just going to put that in order. After 36,000, it looks like 38,000. After the 38,000, it looks like I have 42, and then I have 45. So that's how I just kind of quickly go in orders. I just find the smallest, and I just keep working my way up until I've done the entire data set. So if I'm going to be looking for the median here, the median of the 5 employees' salary is going to be the number in the middle. So that tells me that 38,000 is going to be the median. Now, if I include, oops, I didn't mean to put 500 in there. If I include the owner's salary, that means that's going to be my big one on the end. That now means I have 2 data values that fall in the middle because I now have 6 data values, so I have an even number. So I actually need to find the mean of these 2 middle numbers. So I'm going to take 38 plus 42, and I'm going to divide that whole thing by 2. So I'm adding that in there, that's going to be 80 divided by 2. So if I include the owner's salary, that tells me the median is now going to be 40,000. So notice there was not a huge difference between G and H. So that's kind of cool. The reason is because the median is resistant to outliers. Okay, so this 218,000, it was just tacked on to the end here because it was the biggest value. And so when I'm still looking at the middle 2 numbers, this 218,000 had no impact on it whatsoever. I guess it bumped it up just a little bit because now I'm averaging 38 and 42, but it did not have a significant change to it. So that's something just to keep in mind. The median is often used, especially if you think about home prices, because you can have some really inexpensive homes versus some really expensive homes. So it just kind of it eliminates any kind of outlier affecting your data. And let's see, let's look at the last 2 here. So for J, find the mode of the salaries and do it with the 5 employee salaries. And then again with the owner salary, is there a difference? So notice if we go back up and we look at all of these salaries individually, there is no value that occurs more than once, whether I include the 218,000 or not. So there actually is no mode. And that's just fine. You're welcome to have no mode. You're also welcome to have multiple modes. Sometimes you might have 2 or 3 modes within a data set. That is totally fine, as long as it's the number that occurs most often. Sometimes you might get something that occurs the most often with 2 different data values. That's totally fine. So for part K right here, which measure of central tendency is the best representation of the data? I would definitely say the median. Because it has an outlier in it, it's definitely going to be the one that's going to be resistant to that outlier. All right, so for our last little bit right here, we want to look at weighted averages or weighted mean. So for example, GPA is used with a weighted calculation here. So what we have is, in the example below, the weighted mean is used to compute a grade point average, a GPA. So to compute GPA, each grade is assigned a numerical value. For example, an A is worth 4 points, a B is worth 3 points, a C is going to be worth 2 points, a D is going to be worth 1 point, and an F is worth 0 points. Then each grade for the course is going to be weighted by the number of credit hours that that course is worth. So let's take a look at a particular assignment or particular report card that we have here. So here's just a very typical grading scale right here. If the A is 4 points, B is 3 points, and so on. Here's our report card. So we had a math class. The person got an A in the math class. So I might just remind myself that the grade of A is worth 4 points. So if that is a 3-credit math class, what that's going to tell me is this is actually worth 12 points kind of towards my GPA here, because I'm doing 4 times 3. English was a D, so that's going to be worth 1 point. So 1 times 4 is a 4. Science, they got a B, so that's 3 points. So 3 times 4 is 12. And history, they got a C, so they got 2 grade points for that. So 2 times the number of credit hours, 2 times 3 would give me 6. So all of this over here is the total number that I'm going to add all of those together. So if I add all of those up, I believe I get 34. So this is my total number of points. And then what I'm going to divide this by is my total number of credit hours. So my total number of credit hours would be the sum of this column. So 3 plus 4 plus 4 plus 3, that's going to be 14. So I'm going to take 34 divided by 14, and that's going to give me a 2.4. So what that means is my GPA for this semester would be a 2.4 GPA with all of these grades that I earned throughout the semester. If we change this up a little bit, what if we had actually gotten a B instead of a D in English? So let's get rid of that D and let's make that a B. Let's see how much that can actually affect the overall GPA. So for the math class, we're still going to get 4 credit points for the A, so that's going to give us a total of 12 there. With the B now, remember B's are worth 3, so 3 times 4 gives me 12 points there. I have the B here, so there's another 12 points, and my C is worth 2 points, so that gives me 6. So I can go ahead and add all of those up, and if I do that, I'm now getting 42, and I still have the same number of credit hours, so 42 divided by 14 actually gives me a 3.0 GPA. So going from that D to a B had a really significant impact on the overall GPA. You went from a C GPA because you were in the 2s up to a B GPA because you're now in the 3s. So just something to consider. Do keep in mind our math class for 050 does not affect your GPA because it is a pass-fail course. You will be assigned an A, B, C, D, or F for the overall class, but as long as you get a C or higher, that is a passing grade. And if you get a D or an F, then that means it's not a passing grade and you will have to take this course again. If you have any questions on any of these, as always, pop into office hours, let me know. Connect Math homework will be over circle graphs and measures of central tendency. Thank you, team. Thank you for the